Hello students, let's do lesson 6, esters. Alright, so we will identify and describe significant organic compounds in daily life, draw condensed structural, and line diagrams. Specifically today we're talking about these molecules called esters, and we'll do a little bit of boiling points and solubilities as well. Okay. So remember, we are now over on this side of the chart where we are talking about hydrocarbon derivatives. Now a derivative has something other than C or H on it. So far we've talked about alcohols, halides, and carboxylic acids. And today we'll cover esters. Remember, alcohols are molecules that have an OH, a hydroxyl functional group. R just stands for a long carbon chain, so this could be 3 carbons, 5 carbons, 8 carbons, whatever. Halides have a halogen attached, and carboxylic acids have a double bond to an O and a single bond to an OH. So let's talk about esters. Okay, esters. An ester is formed when a carboxylic acid reacts with an alcohol in what we call an esterification reaction. So, and I'll show you exactly what that looks like in just a second. So here's a carboxylic acid, so this is vinegar or ethanoic acid, and this is methanol, an alcohol. These two can react and form an ester. Now what does it look like? This is going to be a simplified version. We'll probably do an experiment where you'll see we have to add an acid as a catalyst and all of this, but anyway, let's just look at simply what's happening here. Okay, the H and the OH break off like this. The H comes off the alcohol and the OH comes off the carboxylic acid. And they go and form water. And now the alcohol has an electron on that O where the H used to be attached. And there's an extra electron over here where the OH used to be attached. And so we have an attraction here. And these two bonding electrons form a new bond, like so. And now we have what's called an ester. And an ester has a double bond to an O, single bond to an O. There's the functional group for an ester. Not double bond to an O, single bond to an OH, like a carboxylic acid, but double bond O, single bond O, ester. All right. So we have an ester and water as a product of this reaction. Okay, the functional group of an ester is called an ester linkage. That's the double bond to the O, single bond to the O. And R is just a carbon chain. Okay, now R1 denotes the branch. So we have a parent and a branch on these. So it's always the parent, this is always the branch. So in this one, there's our ester. There's our parent, there's our branch. Okay, so the branch will always be the one connected to the O with the single bond, not the double bond. Okay, naming esters. How do we name these? Well, the carboxylic acid is the parent. We drop the oic acid and replace it with OATE. So this used to be our carboxylic acid, and this used to be our alcohol. So the carboxylic acid, its name was propanoic acid. We drop the oic acid, OATE, so that's the parent, propanoate. And the alcohol is considered the branch and is named like the following. That's an ethyl branch. Therefore, this is ethyl propanoate. Now, you could look at it this way too. I often just do it this way to be simple. This is propane, drop the E, add OATE, and this is ethyl. So, ethyl propanoate. Now, I don't know which one you prefer. It's just a little simpler to look at this and go, okay, 3 carbons there. If it was just a straight alkane, it would be propane, drop the E, OATE, and this is my ethyl. But you do need to know that this was a carboxylic acid, and this was an alcohol. Anyway, we'll keep going. Okay, so remember, double bond to O, single bond to O. So what is this? Is this the parent or the branch? Well, that's the branch. The parent is a little hard to see on this one. It's just this point right here. There's only one carbon there. That's the parent. So the parent had one carbon. The branch has two carbons. What's its name? Ethyl methanoate. Ethyl is the branch. Carbon, one carbon for the parent, methane or methanoic acid. Drop the E or the oic acid and add OATE. Okay, now look at this one. You notice how this goes COO. Now, if you see a COO like that in a formula, that's your ester. You can just identify it right now. Oh, there's an ester. And this is the O that has the branch on it, because when we write this, we go C double bonded to an O, single bonded to O. The first O connected to the C is the double bond. This is the single bond. Anyway, this is the oxygen to which the branch is attached. So that's the parent, that's the branch. So my branch is 1, 2, 3 propyl, 1, 2, 3, 4 butane, drop the E, add OATE. Propyl butanoate. Great. Physical properties. Boiling points or lower, because these do not have hydrogen bonds. These are not capable of hydrogen bonding. So you can take a look here. COO, that has a boiling point of 77.1, whereas COOH, the carboxylic acid, had a boiling point of 164, because this has the hydrogen bond. This one doesn't. Okay, and solubility decreases as the chain length increases. In other words, the more carbons we add to the chain, the lower the solubility. Common esters. Animal and vegetable fats and oils are big esters with multiple ester linkages. So take a look here. This is a triglyceride. It contains glycerol. And you'll see on the glycerol here you have a double bond to an O, single bond to an O. This is one of the components of butter. Anyway, so there's these three fatty acids here and glycerol, called a triglyceride. Anyway, these esters are part of animal fats. Alright. They're smelly compounds. That doesn't mean necessarily bad smells. They can be used as additives for foods or perfumes. So for example, look at this one. There's a benzene here, but we also have a double bond to an O, a single bond to an O. That is kind of a wintergreen, like this wintergreen lifesaver. So anyway, there's some common esters for you and what they're used for. Okay.